In this video we're going to take a look at the Unsubscriptions are free challenge from PicoCTF. This is part of the PicoGym, which has challenges from previous competitions, and the description for this challenge says, check out my new video game Spaghetti Eating streaming channel on Twixer. We've got a binary to download and some source code as well, and we've got a server address and port number to connect to once we get things working locally. So let's go and do some basic file checks. So as usual with these challenges, we'll start by checking the file type, and we'll see that it's a 32-bit executable. It's not stripped, so we'll be able to see the function names. We could run checksec, although we've been given a hint that the challenge is going to involve a use after free vulnerability, so this probably isn't too important. But it's good to get into a routine of doing some of these things. We can see we've got some stack errors, and we've got NX enabled, so we're not going to be able to inject shellcode onto the stack. And we're probably not going to be dealing with a buffer overflow at all, seeing as we are probably going to be exploiting a use after free vulnerability, which is exactly what it says, that we try to use some memory after it's been freed. So if some memory is freed and the program doesn't clear the pointer to that memory, we can potentially use that to do some cool things. Alright, so we could try and run the program. I'm not going to do that. I'm just going to open it up in Codium because we've got the source code for this one, as is quite common with the Pico challenges. So immediately we can see that we have a function here called haha exploit go brr, and it's going to open the flag. So let's actually go and create a flag as well. Let me do echo, and I'm just going to send fake flag to flag.txt, just so we know whenever we get things working. Although normally you'll see an error saying, failed to find flag.txt, but in some challenges the program might not even work correctly if you don't have the flag.txt. And it's going to read that anyway into this buffer. So we've got this flag buffer which is created of 200 bytes. It's going to read that in, and then it's going to print out the flag. Alright, so that's our goal. We need to call this function, obviously, so we'll go and have a look. Let's have a look first of all. Is it called anywhere? And we can see it's not called, but we have this function s, which is going to say oop, memory leak, and it's going to tell us what the address of this function is. So that's worth remembering. Let's see what else we've got here. We've got this gets line. Looks like this is just reading in some input, so maybe there's a vulnerability here, but normally if I see something like this, I'll kind of leave it to the end and just see, do we have anything else interesting, because it's probably not doing too much. We've got this struct as well, so we've got a struct which is defined. It's called command, and it contains this function pointer, what to do. So you can see that size 8 bytes, and then we've got a username as well, which is 8 bytes, although remember that we are dealing with a 32-bit application this time, so these won't be 8 bytes, they'll be 4. We also have some variables declared here, so we've got our choice, which is going to be our menu option, and then we have this pointer, which is going to be an instance of this struct, this command, which is going to contain this function pointer and a username as well. Okay, let's see what else we've got here. Let's go down to our main function. So the main function is printing out a menu. We can hit control and click on that to jump to it, and we can see that we've got some different options, and then we've got a function essentially for each one of those options. So it's going to print a menu, it's going to process input, which was reading in our input, and then it's going to do process as user. And do process is basically calling the function which is going to be in this pointer here, this function pointer. Okay, so let's go and have a look at some of these menu options as well. So we can see these are calling the functions, so we've got one for P. We can go and have a look at that. That doesn't actually do anything, so all it does is print out a message. Looks like the same with M. Okay, let's keep having a look through it. Although M will call the function, but it will also set the username, so that user object which is created, it's going to set that username to something that we provide. We've got the leave message as well, which is going to, it's going to malloc 8 bytes and basically read 8 bytes off of us, so it's going to take a message. And what have we missed? It's going to be easier if I scroll up through here. Okay, the other one we've missed is this I, so we can leave, and it's going to free the user. So here's our vulnerability. We're going to be freeing the user, so if we can use this data after it's been freed, hopefully we'll be able to overwrite something in the user object. So it's the user object which is being freed. We know this is the stuff that the user creates, and we know that we can control what goes into the username, and then after it's freed we can also write a message which is going to essentially try and allocate another chunk on the heap, and if there's a chunk available in which is of a similar size, it can be reused. So our plan of action is we want to create a user first of all, to create that user object which was using M, and we want to leak the address of that function, so that was using S as well. That'll leak the haha exploit go burr. And then we want to free the user, so to free the user we can submit I. That's going to free the user, and then hopefully if we go to try to leave a message, it's going to malloc a chunk on the heap and hopefully reuse the chunk that was used for our user object. And because this is running in a loop, it's continuously looping through, as you remember from the main function, calling doProcess. So doProcess is continuously being called with this parameter of user, and if we free the user and then overwrite it with something else, and then this tries to use the user and that pointer still exists, then it'll be pointing to whatever data we've written rather than what was intended. Hopefully that makes sense. Let me open up Ghidra and we'll go and just grab some addresses to go and set up some breakpoints and step through this in GDB and see what it looks like. So I'm going to open up Ghidra with this auto script just to speed things up a little bit. I'll speed this up in the video as well though. Now we don't really need to do this in Ghidra. We could have just gone in GDB and set up the breakpoints we needed, but I'm just going to open it up in Ghidra because then we can have a look at the code, the pseudocode here along the assembly as well. And we want to set up a few different breakpoints. Let's have a look. Where's our malloc here? We've got this user malloc 4 bytes, and that's being called here. So that's going to return the address of the chunk that's malloced. You can see there that's returned into the EAX, and we want to see then what's in the EAX. So we'll set up a breakpoint here first of all. I'm going to take a copy of that. Let's open up GDB-PwnDbg vuln. Let's do break star 0x and paste that in, and there's our first breakpoint. Our next breakpoint is going to be after the free, and the free was in I. So you can see the free here. We're going to set up a breakpoint at the address right after it. Break star 0x. There's our second one. And then our third one we'll do after the next malloc, which is for our message. Let's go to leave message. We've got this call to malloc again, and we're going to set up a breakpoint at the next instruction. Okay, let me minimize this so we can see it a little bit better, and we can run the program. It's going to hit our first breakpoint, which was after our first malloc, and essentially this is the data which has been allocated here, so you can see the address. And we could, let's do x over 8 GWX to print as words in hex. We'll paste that in. I'm going to do -4 as well. So this is the start of our chunk data. That's going to be what's returned by malloc. But if we go back 4 bytes, we've also got the size of the chunk here as well. Now it's actually 16 bytes the chunk. It was supposed to be, I think it was only 4 that was malloced, but I guess it's assigned some extra data. And you have a 1 here as well, which just indicates that the previous chunk isn't free. So that's like a flag to indicate that. So it's actually showing 17, but the size is 16. And at the moment there's nothing too interesting to look at. Let's go and create an account. So we'll do M, enter in a username. I'm going to put in crypto, and let us check that again. I'm going to hit Control and C, and we'll check this. And now you'll see that actually we've got in the function pointer is the first element. Remember, if we go back to our source, the struct has a function pointer first of all, and then that's followed by the username. So our username is down here. We could try to unhex that. Let me try and take a copy. Let's do unhex. It's going to be the wrong endianness, so it's not going to show the right order, but we can confirm that this is crypto in reverse order. Also bear in mind these are pointers, so remember as well, if you go here, this was a char pointer to the username, and then this is a pointer as well to the function. So actually this is the chunk, this is our 2 pointers, this is the struct, and this is the username. So actually if we take a copy of that, let's just do, let me do that again and just change the address. So you see that's the username right there. So this address is essentially this address here. This is just pointing to this username. And we could do the same with this. Let's see what that's pointing to. So you can see it's pointing to the function m at the moment, and we want it to point to this function, which is going to print out the flag. Let's see what the m function was. That was the account created, so that's the last thing that we did. Okay, cool. Let's go back then. Let's also go and free the user, which was I. So I'm going to hit I. It's asking us, do we want to leave? We'll hit yes. So this is right after the free has returned, and let us do the, let's print this again. We can see that the first item of the chunk has actually been replaced with zeros, which is because this will hold the previous free chunk's address. And if we check, let's have a look at heap. If we have a look at the heap, there's only one free chunk available, which we can see is the Tcache, and that's actually the chunk which we've just freed. So the next thing we want to do is go and try to leave a message and see, does this chunk get reused for our message. So I'm going to hit continue. I'm going to go do L to leave a message. We want to submit a message. I'm just going to do AAA. I think we could submit 8 bytes. I'll do 8 A's. Oh, sorry, we hit the breakpoint. We hit the breakpoint right before, sorry, right after the malloc. That's what happened there. So what we want to do is just check this again. Let's see, is it, what's this pointing to? We can see that we've got our username is still in here, but if we look at our EAX, look at this, it's the same address. So basically the chunk has been reallocated. Let's see if we check our heap now. If we check heap, we can see that free chunk that was in the Tcache is no longer free. It's instead being reused, and it means that whatever we enter now is going to be written into the first 8 bytes it was allowing us to write, so the first 8 bytes of the chunk. So we'll hit continue, we'll do AAA, and we get this invalid address. So it looks like we've put together our exploit correctly. We just obviously need to put in the address of the hacked function, the function that's going to print out the flag. So we need to go and leak that. We need to capture it in like a PwnTools script or something, because we can't just type it in. And then we'll submit this instead of the A's, and it'll execute that instead of trying to execute A. Okay, so let me close this down. Let's go and check this out in PwnTools. I'm going to open up Codium, exploit.py, and just paste this in. I set up the breakpoints again in this script, so you can see the breakpoints set up here. This is just a template I use for these Pwn scripts to make it quite easy to swap between local, remote, and debugging, and set up breakpoints and things here. I was having some problems actually. I've been having problems for the past couple of years whereby probably about half of the breakpoints I set up in PwnTools scripts didn't work with GDB. I'd get some error about C-type info not existing, and I actually found out today that it was because Parrot uses a 2-year-old version of GDB. So if I do sudo apt-get install GDB, it's 10.1. Well, I had to go manually update the GDB version to 12.1, so it's 2 years behind. As soon as I did that, the breakpoints instantly started working. So that's going to really help me in future, because it was causing a lot of issues. It basically meant that any time it didn't work in the PwnTools script, I had to go and do it manually in GDB, which made things very difficult. But I'm glad that's fixed. If anybody else uses Parrot, you might want to check that as well. Okay, so let's have a look at our script here. We're going to create a user, sending off crypto. We're going to leak that address. So we'll receive until the memory leak. We drop that because we don't actually want to capture that. And then we take our leak, we convert it into an int, base 16. And then we're just going to print that out just to make sure everything's looking okay. We're going to free the user, and then we're going to leave a message where we're going to send off this address. We're going to pack it with flat, and that's it. It's going to call that function and print out the flag. It prints out a few lines, so I'm just grabbing the second line here, and we'll print it out. Okay, so because we've got these breakpoints set up here, what we can do is just go ahead and run this with GDB as well. So I'm going to do Python exploit GDB. I'm going to minimize this window. Here's the GDB window. It's hit the first breakpoint. So we could take a look at this. This was just the first malloc, if we remember. So it's done the first malloc, I guess. This is the heap address it's grabbed. Let me see. Let's just go and reuse this command. And same thing, you can see here, it's got the size, it's 16 and then a 1 flag to indicate the previous chunk isn't free. We'll hit continue, and now it's set up the user, I believe, so let's do that again. Now we've got the username in here, you can see that's in hex crypto. So that's looking good. Let's hit continue again. And we're now at the free, and you can see the free has reallocated the same chunk to our command that we're about to enter in, or comment, sorry, and it's going to be submitted now, so we'll hit continue, and it just closed. Alright, oh, the flag came on this side, that's why I was wondering where the flag was there. Okay, so yeah, we got the flag. We can do that without GDB quite easily. If you don't like all this output, you can just go into your script and say set this to info or warn or something like that, and then it'll just be a nice neat output, as you can see. And then we can just go and run this against the remote server. So I'm going to type in remote in capital letters. I'm going to grab the server and the port number. I'm going to paste that in. And there is our flag. And that's going to wrap it up for this video. I've left this script on my GitHub, so you can go and check that out if you want to. I'm also probably going to make a short write-up for this one. What I have been doing sometimes is putting up like a PDF document with some notes, so I did do that for this one, whereas unsubscriptions are free. I did that with this one, but it's not very nice with the screenshots. It's taking up a lot of memory and stuff, so I'm actually going to go through and remove some of these, and I think just put them up in Markdown, so it's nicer to read, takes up less memory and stuff like that. So I'll probably do that, and I might start doing that for challenges in future, and then I'll just put a link to the video in the GitHub folder as well. Alright, yeah, any questions or comments, leave them down below. Thanks.